Hello and welcome into the videos for lesson 3. I will typically try to keep the content videos, well, actually the content and the example videos to just one video each. But with lesson 3, we're going through distribution, factoring, and then the binomial theorem. So it's a fair amount of content. So I'm going to break it up into two videos. So part 1 and part 2, as you can see from the video titles. This first part, we'll just look at distribution and factoring, excuse me. And the second part will be just focusing on the binomial theorem. That way too, if you need to go back, say to study for an exam or something, and you just want to know, like, I can't really remember how to do the binomial theorem, let me go check that out. You can just go to that video itself and not have to, like, scan through how many minutes of this first part of part 1 to try to get to it. So let me share the document camera here. So the first thing, let me wait till it gets booted up there. Jump the gun a little bit. Okay, so the first thing we're going to talk about is distribution. And this goes back to like our basic arithmetic properties. So if we're doing multiplication, we can distribute inside parentheses. It can be done with numbers. It can be done with variables. It can be done with a combination. And so if we have like some value A multiplying by a binomial, so bi for 2, nomial is our polynomial, so a polynomial with 2 terms here. We're just going to multiply this a to both of these guys. So a times b plus a times c. So pretty straightforward, pretty standard distribution. I'm assuming most of you probably know how to do that. You probably had to do it for like your ACT, SAT, different standardized tests. We then have, if we have two binomials, we have this concept of FOIL. And FOIL stands for first, outside, inside, and last. So up here, we just had two multiplications that we had to do. Now it's going to be expanded to 4 different ones. And so let's say, as a real basic example, let's do x plus 1 and x plus 2. So I want to multiply these two binomials, so I'm going to first, let me switch to colored pens here, do the first terms. The first term of this binomial and the first term of that one, so that's x squared. Then outside, so the outside of this binomial with the outside of that binomial. So x times 2, which is 2x. Inside, so the inside term of this one and the inside term of that, so 1 times x is just x. Let's see, what else do I got here? Use orange maybe. And then last, so the last term of this first binomial with the last term of the second binomial, so 1 times 2 is 2. Once we do that, then we can combine our like terms. So I don't have any other x squared terms, so that's just x squared. But on these inside, I have 2x plus 1x, so that's 3x. And then this 2 is alone as well. So I get that value. And this can be expanded out to any level of distribution. I could have 3 terms here and 3 terms here. So then I just have to do the first term times everything, the second term times everything, the third terms times everything, etc., etc. So that's our distribution. That's our foiling. So that then takes us to factoring. Now, I can't really cover all the different types of factoring that we're going to encounter, but I'll just highlight a few of them. The ones we're going to see a lot and the ones you should definitely be familiar with. So the first type is just a common factor. So maybe all we can take out is a 2, or maybe all we can take out is an x, or maybe an x squared, something like that. So just a common factor, or it could even be like a 2x or a 2x squared. But that's it. We can just take one factor out of every piece of the polynomial. We have difference of squares. Whoops, difference squares. So as the name implies, difference, meaning we're going to see a minus sign, and then squares. So we're only going to have, first of all, we're only going to have two terms. So if you're told to factor something and you see two terms, the first thought in your head should probably be, wait, is this a difference of squares? Is there a minus sign between them? And then are the values of the two terms, are they perfect squares? And so when we have that, when we have something like a squared minus b squared, the formula for this is a plus b times a minus b. Because that way, if we were to check it and FOIL it back, the outside term is going to be a times minus b, which is minus ab. And the inside is b times a, which is positive ab. So they cancel out. That's why we only end up with two terms. So when I have a squared minus b squared, it factors into a plus b, a minus b. So for example, let's say I have x squared minus 9. Well, I can really rewrite this as x squared minus 3 squared. So it's a difference of two values that are squared. And so then if this is my a and this is my b, this would just become x plus 3, x minus 3. There's not a lot of thinking that has to go into it. We just find, okay, what's the squared value of each of those? And then a plus b, a minus b. We have, if we see 4 terms, this should immediately set off bells and whistles for us that this is a factor by grouping type of problem. And so what we're going to do here is group the first two terms together. So let's do A. Group the second two terms together. So I guess I should make that B. This is C. And once we do that, factor out a common term from each of them. Once we do that, we should have then a common factor should emerge. And then lastly, factor out that common factor. And we'll see an example in the example videos. Factor out the common factor of how that actually works out. So if you haven't done factor by grouping before, you'll see it in the example video. And then the other type of factoring that we have, yeah, let me switch pages. And this you will be doing most of the time is factoring trinomials. So let me just stop here for a second. So factoring is probably one of the most important skills you are going to need for Math 126, Precalculus 1, and Math 127, Precalculus 2. So noted at UNLV. If you're watching these videos and you're not at UNLV, it's still going to be your Precalculus 1, Precalculus 2, because so much of what we do involves factoring. So even if you are not great at factoring, you need to get to the point of being comfortable with factoring. And so, again, you'll have this content, you will have some examples from the example video, you'll have the online homework that you'll be doing, which should give you a lot of practice. But if you're still at the point where you're like, I kind of know how to do this, but I sort of feel like I don't as well, then let me know. I can refer you guys to some different worksheets. What you can do too, I guess now with AI, you could even use AI, but you could just go on to like Yahoo or Google and type in the search bar factoring worksheets with answers. And it'll give you hundreds of thousands of worksheets that people have posted online that will give you more and more practice with these factoring type problems. But factoring trinomials, as the name implies, there's three terms. There's several different ways that these can be done. One is guess and check. But if you're not great at math or you're not great at factoring, guess and check can be a rough way to go about it. There is like a AC method. There's like I've seen people draw like little X's and try to factor it that way. What I'm going to show you is what's called the bottoms up method. This method, so if we had, for example, like x squared, let's use that one we had before. What was it? 3x plus 2. If we have something like this, we can probably use guess and check and get x plus 1, x plus 2. That one's not too bad because there's just the one term in front of here. I just have to figure out the values of 2 that'll get me to 3. So that's not too bad. That's what the bottoms up method does. So let's say we have ax squared plus bx plus c. So this is what's called a quadratic that we're having to factor. That's this guy here. So the first step that we're going to do here, and we're going to assume that a is not 1. And that's when we'll usually want to use this method. So the first thing we're going to do is multiply a times c. We are then going to rewrite the quadratic with our a value being 1, and the c value is now that value we just calculated, a times c. Now that it's in that form, it should be a little bit easier for us. Factor. This is where people think they're done. That's not it. We've only factored the new quadratic that we created, but we have to get back to our original. So what we're going to do from there is we are going to divide each number by our original a. Once we do that, simplify the fraction if possible. And then once we've done that simplification, move the denominator in front of the x. and that will get us the factoring of our original. So let's look at an example to kind of see how this goes through. I'll sort of slide it up and down as we go here. Let's say I want to factor 3x squared minus 16x plus 5. So maybe we can do this by guess and check, but maybe we're having an off day and it's like, man, I just can't come up with the numbers to get this. So we're going to do bottoms up. So first thing I do, I multiply a times c. 3 times 5 is positive 15. So positive 3 times positive 5. If this was a minus, make sure you include the minus as well. So that was step 1, multiply a times c. Step 2, rewrite it, but now get rid of this 3. So that just becomes a 1 in front. The middle term stays the same, but instead at the end of plus 5, I'm going to use this guy, plus 15. Now go ahead and factor this. So now all I have to do is find two numbers that when multiplied together give me positive 15. But if I add or subtract them, give me negative 16. So that's what? Negative 3 and negative 5. So x minus 3, x minus 5. If I want to check, FOIL it back. I'm sorry, not negative. I don't know what I was doing, negative 3 and 5. It's negative 15. Sorry. You're like, what is this guy talking about? I don't even know what I was talking about, why I did that. It's negative 15 and negative 1. So when I add those together, give me negative 16. Sorry, I don't know why I did that. And if I was skilled, I could probably go back and fix this video, but we'll just move on here. So instead, minus 15 minus 1, so x minus 15, x minus 1. So how did I catch that error? Maybe it's a good thing that I screwed that up. How did I know that that was wrong? Well, because if I would have tried to FOIL this, I was not going to get this quadratic back. But when I FOIL this one, this will give me x squared minus 16x plus 15. So now I know that this is right. And again, I apologize for doing the 3 and 5. I don't know where that went, but anyhow. All right, but we're not done. This is the factoring of this guy, but that's not what we started with. We started with this one. So what do? Well, I divide each number by the original a. And my original a was 3, so I get x minus 15 over 3 and x minus 1 over 3. Now, simplify these fractions if I can. So this one becomes x minus 5, and this one won't simplify. So it's just x minus 1/3. Now take the denominator. There's the denominator of 1 here, so I'm not really going to do anything with that one, x minus 5, and move the denominator in front of the x. So 3x minus 1. Now we are done. But again, my suggestion, especially if you're not great at these, or if this is on a test and you're told to factor this, and you're like, man, I want to make sure I get 100 on this. Let me FOIL it. So x times 3x, 3x squared. Minus x minus 15x is minus 16x, and negative 5 times negative 1 is plus 5. So I am 100% sure that is the factoring of the value that we started with. So again, you can always use FOIL. Go back and check yourself to make sure that what you assume to be the factor is in fact the true factoring. I believe that is it. Yes. Okay, so that is the end of lesson 3, part 1. That's on our distribution, foiling, factoring. Come on back for the second video. We'll talk about the binomial theorem there, and then we'll get into the example videos for lesson number 3.